Here we are looking at the general definitions of trigonometric functions, and here we are told let theta be an angle in standard position, and let xy be the point where the terminal side of theta intersects the circle x squared plus y squared is equal to r squared. And here is a circle centered at 0. This is the terminal side, and theta, let me show where angle theta is. So this is theta, and you are told, and then moving on, let's move on with the statement. And a triangle is formed by drawing a vertical line from the point to the nearest x-axis. So let's make a triangle, and the triangle is going to be right there. That's the right triangle, and I can make, let me draw that triangle here so we can be able to see it better. And remember, this is x, this is y, and this is the radius, and the angle theta is right there. And then we can be able to get the 6 trigonometric functions. So for sine, remember sine, and here we got to remember, so katoa, and sine is opposite of hypotenuse, so that's going to be y over r. And then let's go to cosine. Cosine is going to be x over r, which is adjacent of hypotenuse. And then let's go to tan. Tan is going to be y over x. And then cosecant is a reciprocal of sine, so it's going to be r over y. Let's go to the other one. Secant is the reciprocal of cosine. It's going to be r over x. And then cotangent, reciprocal of tan, so it's going to be x over y. And those are the general trigonometric ratios. Suppose now I'm given a point on, using the given point on the terminal side of an angle in standard position, evaluate 6 trigonometric functions. So I'm going to draw that, and then this point is at 8, 15. So this is 8, and it's just approximation, 8, 15. So that's the point there. And what I'm going to do, this is the terminal side. I'm going to make a triangle, and this is theta right there. And note that, see my triangle, if I draw my triangle here with all the measurements, okay, so this is 8, this is 15, and then I can use Pythagorean Theorem to find the missing side. So to find, let me call this r. R squared is going to be given by x squared, which is 8 squared plus 15 squared, and this is going to be 64 plus 225, which is equals to 289. So the radius squared is 289, so r is equals to 17. So this missing side is 17. And now let's get our ratios. So we start with sine of theta is equals to 15 over 17. And then we do cosine of theta is equals to 8 over 17, and I'll just leave it as a fraction. And then tan of theta is equals to 15 over 8. And same way we can get the reciprocal functions. So secant of theta is equals to 17 over 8. 17 over 8, let's get cosecant of theta. Cosecant of theta is going to be 17 over 15. And then I can get cotangent of theta, which is going to be 8 over 15. And now the next thing I'm going to find is what angle is this. So theta, how do I find this angle? I can be able to use any of the ratios I have. I'm going to use sine, but this time I need sine inverse of 15 over 17, and then I'll use my calculator. And when I use my calculator, I'm going to get that this angle is 61.93 degrees. And see, what is the reference angle? I can also find the reference angle while I'm still here. Reference angle. See, this is an acute angle. So all angles in quadrant 1 are their own reference angles. So the reference angle here, remember the symbol used for reference angle, is just going to be 61.93 degrees. So that is the theta we have been using over here. Okay, here let's do another example. And here I draw my triangle. So this is -2, -3, so -2, -3. So my triangle is going to be here. Now I make a triangle with the nearest x-axis and the terminal side, and here is theta. So let me draw my triangle here, and I just want to use the same orientation so that we can be able to follow along closely. Okay, so this is my triangle, and this is theta, and this is -2, this is -3, and let's get the ratios now. So I need to find the missing side here, and the missing side, so the radius is going to be given by 2 squared plus 2 squared. Remember the distance is positive, so it's just 2 squared plus 3 squared. So that's going to be 4 plus 9, so that is 13. So R is equals to square root of 13. So now we can get the ratios. Let's start with the sine of theta. Sine of theta is going to be, so remember this is square root of 13. So sine is going to be opposite, so -3 over square root of 13. And then we go to cosine of theta, which is going to be adjacent, so -2 over square root of 13. Then we go to tan theta, which is going to be -3 over 2, which is just over -2, so which is 3/2. And then here we can get the reciprocal functions. So cosecant of theta is equals to -square root of 13 over, so square root of 13, let me write this again, is equals to -square root of 13 over 3. Then we go to secant of theta, which is going to be negative square root of 13 over 2. Then we go to cotangent of theta, which is going to be 2/3. And then the last thing we're going to do here is to find the angle. So theta is going to be, I can use any ratio, so I can do sine. So this is going to be sine inverse, why am I writing 2? Sine inverse of, and sine inverse of, or I can use sine inverse of square root of negative 3 over square root of 13, and this is going to give me the angle which is in third quadrant, which is 100 and, no, not 100, but 236.31 degrees. And what is the reference angle? The reference angle, I can get it by subtracting 180 from there, from this angle. So this is theta, but the reference angle, I subtract 180 because it's in quadrant 3, so I get 56.31 degrees.